Welcome students to my home. I'm going to share this last section of memory. It's about how we can improve memory, and so this will be a relatively short section. And one thing that we can do to improve our memory, something we've already done, is use mnemonics. And mnemonics are like tricks or strategies that we can use to improve memory. I think many of you are already familiar with one trick that many people use. Roy G. Biv. Anybody know who that guy is? Of course, many of you know that we often memorize that to help us remember the colors of the rainbow, and really what we're doing is we're remembering the order of wavelengths in the visible light spectrum that goes from from long to short. So long wavelengths are red and the shortest are violet, and you can use the first letter of every word to get red, orange, yellow, green, blue, indigo, and violet. And so Roy G. Biv is a great easy strategy to learn those 7 colors. So that's what we mean by mnemonics, things that can improve your memory. Another one is the peg word method that, of course, you're very familiar with. And so that's another trick, right? So I have learned, and maybe you can learn too, those 10 words that go along with the numbers 1, 2, 3, 4, 5, which is 1, bun, shoe, tree, door, hive, and 6, 7, 8, 9, 10, which is sticks, oven, plate, wine, and pen. And so we use those 10 words then as sort of pegs, if you would, that are already in our minds to associate new words with them. So hopefully you can remember perhaps what the second word is on our list, or the fifth word, and so forth, from only spending some 20 seconds studying it. And we can't use these mnemonic devices for everything, but the important principle for you to get from this is why they work. They work because they give organization to our memory, right? We have connections. We've already talked about semantic networks and how we have a whole group of memories that semantic network we might call a schema, right? So we have a schema about Thanksgiving, or we have a schema about Easter, and we have all those related memories that are part of that conglomerate associated with Easter or Thanksgiving or a group of people or whatever it might be. And those memories are very interrelated and connected. And so that once you think about Thanksgiving, you easily think about pumpkin pie and football and family and turkey and so forth. All those things are easy to access. Well, that's the kind of thing we do with the peg word method, is that you have a word that you already know well, like tree or door or hive, and you connect it with this new word so that that connection then can be utilized. So we're using an already existing network and fitting it in there. And that's how it works. Now, if you remember, we also said it was very important to be visual, which is another aspect of it. So we thought of these associations in very unusual ways. And indeed, we can remember pictures often much better than words. Now, we've talked about different reasons why we forget, and one problem in our memory is we have to make sure that we actually get it into memory. And so some of the problems can be that we just fail to encode the information very properly. And what I want to show you in this screen here is to illustrate the various different forms in which we can encode information. So as you can see there, we can have motor encoding. So there's some information that is in essence these muscular instructions that move my fingers as I type, right? So all I got to do is think of the words and my fingers move to do the typing on the letters. Or people who are really good with musical instruments, who can play the piano and so forth, can be very good at that. And so it is a type of encoding memory that is very enduring. That's the word that belongs in that blank, enduring, meaning it's very long lasting. The second form is visual encoding. As we talked about before, and we talked about working memory, and we talked about that visuospatial sketch pad, right? there has to be some visual representation of your kitchen or of your dining room that you can bring to your mind, right? And you can sort of see that visual image of your dining room. So that's what we mean by that. Auditory encoding is we can hear sounds and the sounds of the words, or if it were a song, for example. So that is one that we use very often when we're doing maintenance rehearsal. So when we were doing the little memory test I gave you, where I gave you a bunch of nonsense syllables like pid, lom, fic, wan, tub, as you silently in your head said pid, lom, fic, wan, tub, what you are likely doing is memorizing the sounds of those words that you are listening to. And so we were using that acoustic rehearsal loop that we defined earlier, and it's those sounds that you're remembering. And the final way of encoding is semantic encoding. And semantic is a word that we're going to encounter a number of times throughout this course. And it means, first of all, any word that ends in IC means pertaining to, and it means pertaining to meaning. So it's about meaning is what semantic means. And what this information is like most of the words that we have to deal with in this course require semantic encoding. And this information is stored as propositions. So just as you see in that box to the right there, it is stored as propositions. And so what we do is we convert that information that we may be reading in a textbook, or if we read in a definition, and we break it down into several single propositions or ideas. So a proposition is a single indivisible idea. So another way of describing it formally, we call propositions the smallest piece of information that can be true or false. So look at the example to the right there of a proposition, right? So imagine that you find in your textbook a definition of the medulla. So that's a part of the brain that we're going to be describing very soon in the next block. And so as you see there, you might read a part of the brain at the top of the spinal cord critical for vital functions. So if we look at that one sentence there, there are actually 3 different propositions contained in there. One unit of information, I sometimes call them factoids. One factoid is it's part of the brain. Another part of that sentence is it's at the top of the spinal cord. And the third part is that it's critical for vital functions. And I would venture to say that if you were trying to memorize what medulla is, you would be much better by trying to learn those 3 propositions than trying to memorize that sentence. So what is the medulla? Oh, I know. There's 3 things I need to know about that. It's part of the brain, top of the spinal cord, controls vital functions, as opposed to remembering the whole sentence. Let me give you another example. Many of you have already come to me and have sought help in how to employ the study card method. And I encourage every one of you to consider that option as you look for different strategies. Remember, as I've said a number of times, the biggest problem students have and why they're not successful isn't because they're not intelligent or they're not capable, but rather they're not using the right strategy and the right degree of effort. And so I'd be glad to talk to you about different strategies, and this is one that I advocate. And part of the technique of using study card method is breaking down complex definitions or concepts into propositions. So let's look at this example. So let's see you're reading in the textbook about genes, right? And so in the textbook it says, or in your notes or whatever, genes are the basic units of heredity that consist of a small segment of the DNA molecule which code for the structure of proteins. So if I find this in your list of concepts, hopefully you've all seen those list of concepts that we have for every block of material. And so if you look at that list, this is one of them for the next block, describe genes and what they encode. So given what you read there, right, that sentence above, which is some 24 words long, what are the 3 propositions in there? So take a moment and think about, well, what is one unit of information in there? Well, I hope you see the first one, of course, is that it's a basic unit of heredity. So that's one thing you need to know about genes. What else? It's a small segment of the DNA molecule. Third, it codes the structure of proteins. So try to remember these three things, these three propositions, versus that 24-word sentence. I suspect you're going to have much greater success. And the reason you have much greater success with this study card is because it's taking advantage of how your memory works. How do we remember and code things semantically about meaning? We do it through propositions. If you think about these little units of information, when we saw those semantic networks before, when we talked about, I forget where we have, a bird has wings, a bird likes worms, a bird, each of those are little factoids or propositions that all make up that network that we saw whenever we describe the sort of system of long-term memories that we have. Now, another aspect of encoding is effort. As you know, sometimes remembering things are easier than others. So when we look at the amount of effort we have to put into actually memorizing something, there are some that is pretty easy in that it's sort of automatic. And so it's sort of automatically processed. In other words, we automatically remember it. So for example, unknown to you or in the background and transparently in the background, your mind is calculating where you are and where you've been. So as you have come to class or wherever you are, you can typically retrace the steps that you got there. But think about that. That requires a memory. You have to remember the path that you took here. But certainly as you were walking to class or walking to your dorm, you weren't constantly rehearsing, I better remember the way I went across the street here, or the fact that I stopped at Bentley, or whatever path you may have taken. That is sort of automatically encoded. And you think about it from an evolutionary perspective, that makes a lot of sense. In other words, that's some pretty darn important information that has everything to do with your likelihood of success in living and reproducing, is being able to find your way back. And so our brains are well designed to easily learn that information. Similarly, our brains are very well designed to learn and remember faces and where we've been. So those are two examples. Another one is the frequency of experiencing the situation. We're often very accurate knowing when we've been to this particular building before. And again, those things are being learned automatically in the background. Now, I wish that was the case for all the work that we do in college, but clearly very little that fits into that realm. That what we have to do, because it depends on our verbal abilities, and our verbal abilities, and particularly written materials, is something that is extraordinarily recent in evolutionary time. So we've only had the printing press for a little over 500 years, and most people, of course, weren't literate and couldn't read, and so our brains are not specially adapted to remember the printed word, which is why it's so daggone hard to remember a 24-word sentence. So if you rehearse that definition of genes and you use that 24-word sentence, you'd likely do very poorly. So it requires some effort. And so we can often boost our ability to encode information if we rehearse it. And there's two very different kinds of rehearsal. In maintenance rehearsal, this is when we just repeat the material all over again. This is what we were talking about when we were talking about our working memory, and we use the articulatory rehearsal loop. That is, I just say, pidlam fic one tub, pidlam fic one tub, pidlam fic one tub, pidlam fic one tub. And it uses acoustic or auditory encoding. You're hearing yourself say those words. And the same would be true if I just kept rote rehearsal, reviewing my notes, saying it over again. Well, classical conditioning, a form of learning where a neutral stimulus gains the power to elicit an automatic response. Classical conditioning, a form of learning where a neutral stimulus gains the power to elicit an automatic response. So if I just keep reading that over and over again, that's maintenance rehearsal. it keeps the information active, right? And it can create the illusion like you really know it, but unfortunately, it has very poor long-term retention. So if you want to learn something and have it last and be able to recall it a long time later, that's a very poor way to do it. So what we want to do is do a more elaborative rehearsal. So this is where we're going to use semantic encoding, we're going to use visual encoding, and we're going to use, an organization. And these are all things that occur using that study card method. So semantic encoding is I take whatever that definition of learning of classical conditioning might be, or genes or medulla, and I break it down into its component parts. I break it down into the propositions. I also take advantage, if there's any way that I can use a picture to substitute for words, that's a huge advantage. And so I'll employ that so that I have a much better way of remembering images than I do words. So if I can substitute an image for a word, for example, like where the medulla is in the brain, that would be a much advantage. And then I have it organized so that, when I try to learn information, I know what it's a part of. For example, I might learn that not only is the medulla important for vital functions like heart rate, but it's also part of the reptilian brain. So I see that it is a subset of this bigger thing. You got the reptilian brain, which has the medulla and the pons and the midbrain and the cerebellum and so forth. And so I know that it's part of this bigger thing. So that's making it organized, just like we do in the pegword method, helps us to remember the information. So when we do that, when those proposition and images are linked together in a complicated web of knowledge, that's the word there, we get very good long-term retention. So part of that elaborate rehearsal is organizing information, right? When we organize it, that Roy G. Biv, that's an example of chunking, right? So I take those 7 color words and I put it into one person's name. So that makes the load my mind much easier to remember those 7, and not only remember them, remember the order of them. And so that's very useful. We're going to do the same thing with the word ocean when we get to personality. There's big 5 parts of our personality, and it fits the word ocean. We have openness to experience, conscientiousness, extroversion, agreeableness, and neuroticism. And so we can helps us remember that information. Creating hierarchies, like in this handout, right? So I have the effort encoding. Well, there's 2 kinds of effort. And then when I look at effortful processing, there are 2 kinds of that. So that kind of organization helps us remember information. And finally, we can further enhance a recall of this and retention by both overlearning. So in other words, don't ever get worried that you've learned too much or you're practicing too much. You can always go to inquisitive and keep practicing. So even though those other chapters are complete, you should still go back and continue to rehearse. There's definitely no harm in that, and there's clearly an advantage to overlearning, and there's an advantage to self-referencing. So if you're giving an example of classical conditioning or operant conditioning or whatever the concept might be, if you can connect it to yourself, to your own personal experience, because those memories of your personal experience, they're already in your mind, just like those peg words of bun, shoe, tree, door, hive are already in your mind. So if I can connect this new concept I'm learning in Introduction to Psychological Science to those memories I already have, it's going to be a lot easier to recall. Well, that's the end of this section. I hope you have enjoyed this time, and onward to the exam.